This is taken from Gerard Hickson's King's Dethroned book. And before I read this, let's see. If the principle of relativity is that the laws of physics must remain the same in all inertial reference frames, doesn't that mean that the laws of physics must therefore change to remain the same? Right? Because we're going to get into how ridiculous relativity actually is and how broken our education system is. That's a really interesting way to put it. You've hit on a subtle but crucial point about the principle of relativity. You're right that the principle states the laws themselves don't change from one inertial frame to another. However, to ensure these unchanging laws hold true when observed from different perspectives, some things we might intuitively think of absolute do have to change. For context, Einstein is like my worst nemesis. The man, the myth, the legend that has been pounded in the kids' minds from an early age. Right? He is a bona fide moron. Well, he's not literally a moron, but he ended up being one of his theories that he propounded, that are attributed to him anyway, are some of the worst theories that have been perpetuated upon the human race and have been the absolute detriment of physics for the last 100 or so years. Continuing, think about it this way: the law is constant, observations differ. The change to remain the same, to reconcile these different observations with the same underlying laws of physics, the law of gravity and Newton's laws of motion, our understanding of space and time needs to be flexible. Okay, here we go. This is where Einstein's theory of special relativity comes in. It shows that things like relative velocity and the velocities of objects are different depending on the observer's frame of reference. This is intuitive. Time dilation. Bum, bum, bum. Time can pass at different rates for observers in relative motion. This is less intuitive, but necessary to keep the laws consistent. I agree, it is necessary, which means that Einstein gave himself and other physicists the right to literally change time itself. Length contraction. The length of an object can appear different depending on the observer's relative velocity. Again, this ensures the laws remain consistent. Which is to say that, right, this is directly what I was looking for, so I'm glad they threw this in here. Time dilation and length contraction. Einstein took it upon himself to quite literally alter time in physical dimensions like length, width, height, right? Literally altering these things, both physical dimensions and abstract dimensions like time, changing them to fit his theory. If that's not metaphysics, I don't know what is. And this is, mind you, how they explain away the Michelson-Morley test. Watch. Is the Michelson-Morley experiment explained by length contraction? Yes, the null result of the Michelson-Morley experiment can be explained by the phenomenon of length contraction, which is a key component of Einstein's theory of special relativity. Which is to say that because the Michelson-Morley experiment yielded a null result, which means that it showed that the Earth was not in motion. They keep talking about this whole ether. It was meant to test the ether. No, stop. Look, it produced a null result, meaning that there was no motion of the Earth observed. That's what that means. Don't even worry about the ether. Right? I've had to figure this out for myself, and it's just, this is a red herring. Don't even worry about the ether. It's about space itself. And the Michelson-Morley experiment showed that there was no movement of the Earth, which is why they came up with length contraction, right? To literally alter the observations. Chapter 12, Relativity. The theory of, and this is from the early 1900s, back when relativity was still brand spanking new. The theory of relativity is so complicated that when it first came to the public notice, it was said that there were probably not more than 12 people in the world capable of understanding it. But public interest was aroused, partly by the novelty of Einstein's hypothesis, and partly by the spectacular manner in which it had been received by the British Royal Astronomical Society. On the night of November 6, 1919, until Mr. Eugene Higgins of USA offered a prize of $5,000 for the best explanation of relativity, in the form of an essay, describing it that the general public could understand what it was all about. The prize was won by Mr. L. Bolton. The editor of the Gazette found it necessary to remark when publishing the essay that our readers will probably agree that even when stated in its simplest form, it remains a tough proposition. That is just the trouble with it. It is about as far removed from ordinary fact and plain English as it is possible for anything to be. Indeed, it is so intangible that it may well be that Einstein can form a mental picture of it himself, while he is at the same time unable to convey his meaning to others through the medium of ordinary language. The thing is elusive, abounding in inference, suggestion, half-truth, and ambiguity, wherefore it follows that any discussion of it, such as we propose to enter upon, must of necessity be almost equally refined. It might seem torturous to some readers, and yet be like a very entertaining game of chess to others, while it certainly will be useful to those who are willing to traverse the long and difficult labyrinth that leads to truth. Relativity is clever, but it belongs to the same category as Newton's law of gravitation and the Kant-Herschel-Laplace nebular hypothesis, in as far as it is a superfine effort of the imagination, seeking to maintain an impossible theory of the universe, in defiance of every fact against it. Let us see what we can do with it. First, we will let Professor Einstein himself tell us what he means by relativity, in the words he used in the opening of his address at Princeton University, USA. Quote, "What we mean by relative motion, in a general sense, is perfectly plain to everyone. If we think of a wagon moving along a street, we know that it is possible to speak of the wagon at rest, and the street in motion, and just as well as it is to speak of the wagon in motion, and the street at rest. That, however, is a very special part of the ideas involved in the principle of relativity. That would be amusing if we read it in a comic paper, or if Mutt and Jeff had said it, but when Professor Einstein says it in a lecture at Princeton University, we are expected not to laugh. That is the only difference. It is silly, but I may not dismiss the matter with that remark, and so I will answer quite seriously that it is only possible for me to speak of the street moving while the wagon remains still, and to believe it when I cast away all the experience of a lifetime and am no longer able to understand the evidence of my senses, which is insanity. Such self-deception as this is not reasoning. It is the negation of reason, which is the faculty of forming correct conclusions from things observed, judged by the light of experience. It is unworthy of our intelligence and a waste of our greatest gift. But that introduction serves very well to illustrate the kind of illusion that lies at the root of relativity. Throughout the whole of his theories, there is evidence that Einstein was thinking almost entirely of their application to astronomy. But it was inevitable that this should involve him with physics, so that he had then to engage upon a series of arguments intended to show how his principles would work out on the plane of general science. The first may be said to be the motive that inspired him, while the second consists of complications and difficulties which he could not avoid. And when he suggested that the street might be moving, while the wagon with its wheels revolving was standing still, he was asking us to imagine that in a similar manner, the earth we stand upon might be moving. That the earth we stand upon might be moving, while the stars that pass in the night stand still. It is a case of appeal, where Einstein appeals in the name of a convicted Copernican astronomy against the judgment of Michelson-Morley, Nordmeyer, physics, fact, experience, observation, and reason. We, on the other hand, are counsel for the prosecution, judge, and jury. Under the general heading of relativity, Einstein includes an assortment of new ideas, each of which depends upon another, and each of which contribute to support the whole. He says that there is no ether, and that light is a material thing which comes to us through empty space. Consequently, light has weight and therefore is subject to the law of gravitation, so that the light coming from a star may bend under its own weight, or deviate from the straight line by the attraction of the sun, or of any other celestial body it has to pass in its journey to the observer on Earth. In that case, it follows that no star is in reality where it appears to be, for it may be even as suggested in diagram 26. Consequently, the heavenly bodies may be much further away than they have hitherto been supposed to be, and every method which is based upon the geometry of Euclid and the triangulation of Hipparchus will fail to discover the distance to a star, because its real position is no longer known. Wherefore Einstein has invented a new kind of geometry in order to calculate the positions of the stars by what is nothing more or less than metaphysics. We have always been accustomed to measure things by the three dimensions of Euclid: length, breadth, and thickness. But Einstein, thinking of astronomy, says that time is a fourth dimension, and proposes that henceforth things should be measured on the understanding that they have four dimensions: length, breadth, time, and thickness. The introduction of time as a fourth proportion of things makes it necessary for him to invent a number of new terms, and also to change the names of some of those that we already know and commonly use. Thus, for example, space is changed to continuum, while a point is called an event. Time, as we have always understood it, no longer exists, and is said to be a fourth dimension, while there are no such things as infinity or eternity and relativity. That is the case for Einstein. It is the essence of his relativity, clearly stated in plain English. The details of it represent an immense amount of labor, of a refined character. The whole thing is very imaginative, and the work of an artist in fine-spun reflections. Indeed, it is of that double-distilled intricacy which finds favor with those who like mental gymnastics and hair-splitting argument, and are fond of marvelous figures. But I can conceive that in the course of time this relative phantasmagoria might come to be regarded as science, and be taught as such to the children of the near future, and that is to be prevented only by dealing with it now, which I will do, though I grieve to give so much space to a matter which only calls for it because it is so pernicious. Alright, now I'm going to see if I can find where he actually addresses the principle of relativity itself. I believe it's on page 73. I mean, this entire thing is worth reading, but here we go. So much for Einstein's second law. Now let us examine the other, the first law, or as he calls it, the principle of relativity. You're a good boy. Sorry, my cat's messing with me. The principle of relativity, which states that all inertial systems, that is, all systems which move with uniform and rectilinear velocity with respect to each other, are equivalent in expressing the laws of natural phenomena. That is what the law is stated to mean. It may not appear very inviting to the general reader, but he will find it quite interesting as we proceed, though it is, of course, of very great importance to every student of general science and mechanics. As a matter of fact, it is not a law at all. It is a statement. At the same time, it is not a plain statement, for it is equivocal and means something which it does not say. It is a statement by implication. It is as though we were to say, "Hello, Jones, how long have you been out of Gaul?" That would make it necessary for Jones to prove that he had not been in Gaul in order to dispose of the implication, and so it is with this statement of the principles of relativity. It is an implication. Taken literally, it is true, for it states what is already known, but it implies the reverse of what it states, that all systems which do not move with uniform and rectilinear velocity with respect to each other are not equivalent in expressing the laws of natural phenomena, and that is very much more important. Now, if we carry this innuendo to its logical conclusion and put it into some simple language, it means that no reliance can be placed upon any deductions which are obtained by means of observations to the heavenly bodies, because they are taken from the surface of the earth, and the observer is moving at a different speed than the object under observation. there would be a certain amount of truth in that if the Earth was really moving, though, even if that were so, the effects of relative movement could be easily overcome by taking two observations simultaneously from opposite sides of the meridian to which the object was vertical. The effects of time would be eliminated in that way, and a mean would be found by comparing the two opposite observations. And so we find that neither the statement or law or its implication have any value. The statement might just as well have never been made. With mental agility worthy of a better cause, Einstein leads from his mechanical principle of relativity up to the special principle of relativity, by means of one of the most extraordinary arguments it is possible to imagine. But strange as it is, and inconsequential as it may seem, this argument really affects everything that comes within the range covered by the word relativity, and for that reason we will not allow it to pass unnoticed. After admitting that electromagnetic laws do not alter according to the system in which they occur, that is to say, after admitting that electromagnetic laws act the same all the world over, he proceeds to argue precisely the contrary by saying quite definitively that in reality they do alter, and offers to prove it by the following statement. The motion of each locality on the Earth is constantly changing from hour to hour, but no corresponding changes occur in electromagnetic action. Of course, this has all the appearance of a man flatly contradicting himself, and it might even appear to be nonsense, but in reality it is a very pretty argument of the most elusive kind, which it is a pleasure to meet. I will confess that I admire Einstein. He skims so close round the edge of the ice. What he suggests is this. The observer is located on the surface of an Earth, which is rotating on its axis, at the same time traveling through space at many thousands of miles an hour. Consequently, his place or locality is continually changing with respect to an imaginary point fixed in space. Notwithstanding this change of place, electromagnetic laws appear to act precisely as they would if this place was not changing its position with respect to that point. Therefore, Einstein argues that electromagnetic currents must, in reality, vary their speed, and so adapt themselves to the changing conditions in such a manner as to seem the same to the observer as if he had not changed his position. Fine, here, go back up. The change to remain the same, right? Unfortunately, he is unable to show any reason why electromagnetic action should do this remarkable thing, for he treats it as a thing that had intelligence, as if it willfully acted in a manner calculated to deceive the observer. When reduced to his essence, this argument proves to be no more logical than the idea that the street might be moving while the wagon was at rest. Einstein has been betrayed into supposing a thing that is altogether impossible, i.e., that a physical law can act in an unnatural manner, and yet produce an effect which appears to be normal, because he began by assuming that the locality of the observer was changing, and that assumption was untrue. Now, if he can realize the fact that the Earth is actually at rest, he will find that his difficulties all disappear, and that electromagnetic laws do not alter, neither does the locality of the observer change. Right, which is the reality of the situation. It's not the first time that I've heard that. The funny thing about Occam's razor and how heliocentrists try to apply it continuously to their own belief system is that the heliocentric viewpoint is it is the absolute opposite of Occam's razor. Now keep in mind that that's a logical fallacy within itself. Just because something is simpler doesn't mean that it's true. But the notion that the heliocentric universe is the simplest to explain is absolutely fucking asinine. It is fucking asinine. Watch my video on gravity is not real if you don't fucking understand that. And I make it a bit clearer in that video just how fucking absurd those viewpoints actually are. And this is the type of poison that has been indoctrinated into people their entire lives. Right? Like, I'm not joking when I say that I cannot stand Einstein. He's like my fucking arch nemesis. And these individuals have been, society at large, the world over, has been taught to believe that this is one of the greatest minds in history. It's like this is single-handedly one of the worst things to have happened to the world of physics. Physics has been in a rut for at least 500 or so years now. That's not an exaggeration. That's how bad it is. The entire situation is terrible. All right, much love.